Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic, NVIDIA and Corning have announced a major strategic partnership for AI infrastructure optical connectivity. The race for AI is no longer just about computing power. It's about how fast data can travel between chips.
As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Think of today's story as a tale of a giant cooking factory that's run out of hallway space. So sit back and enjoy. Imagine an AI data center as a supergiant cooking factory that answers questions from people all over the world. The stoves in the factory are the GPUs, the chips that do all the computing. When a customer places an order, think of that as someone asking an AI a question. The factory cooks up the answer and delivers it. That's the basic picture. Up until now, the competition has been all about making those stoves more powerful. First, you had stoves that could cook for 1,000 people, then 10,000, then 100,000. NVIDIA became the world leader at building these super-powered stoves. But here's where a new problem appeared. No matter how many stoves you add, if the corridors connecting them throughout the factory stay narrow, ingredients and finished dishes pile up in a massive traffic jam, and nothing actually reaches the customer. The corridors used to be made of copper wire. For short distances, that worked fine. But as data centers kept growing bigger and bigger, those corridors stretched to hundreds of meters. And the longer the copper wire, the weaker and slower the signal becomes. That's where light corridors come in. Optical fiber. Light carries information over long distances without losing strength, at incredible speed. Connect stove to stove, shelf to shelf with light, and the traffic jam disappears. Let me summarize the cooking factory stance. The hero of this story is a company called Corning. Corning has been around for over 170 years and is one of America's oldest glassmakers. In fact, they manufacture much of the optical fiber used around the world. In our cooking factory analogy, Corning is the team of professionals who build the finest light corridors in the business. And honestly, my current position on this NVIDIA Corning partnership is almost exactly the same as this cooking factory story. NVIDIA invested a massive $500 million, over 70 billion yen, directly into Corning. On top of that, Corning plans to expand its optical fiber manufacturing capacity by 10 times. The kings of the stove business teaming up with the kings of the corridor business. To me, this is a declaration that they're changing how the entire cooking factory is built. Let me get into the specifics. In this deal, NVIDIA acquired the right to obtain up to 18 million shares of Corning stock. The total investment is approximately $500 million. This breaks down into 15 million warrants exercisable at $180 per share, plus 3 million pre-funded warrants with an extremely low exercise price. On Corning's side, they announced plans to expand US-based optical connectivity manufacturing capacity by 10 times and increase optical fiber production capacity by more than 50%. They'll establish 3 advanced manufacturing sites across North Carolina and Texas, expected to create around 3,000 jobs. Until now, discussions about AI semiconductors have centered almost entirely on GPUs. Performance, power consumption, memory bandwidth, all the conversation has been about the chip itself. But as AI data centers continue to scale up, computation alone is no longer the only bottleneck. How do you connect GPUs to each other? Servers to servers? Racks to racks? The communication infrastructure has become the next bottleneck. The king of GPUs, NVIDIA, and the king of optical communication, Corning, have joined forces and moved early. That, in my view, is the real essence of what's happening here. In my estimation, NVIDIA is no longer just a company that sells GPUs. They're moving toward building AI systems that function not as a collection of separate components, but as one unified optical computer. That's what I believe their true ambition is.
This is where CPO, co-packaged optics, becomes critical. CPO replaces the electrical connections between chips with optical connections. Electrical signals lose significant energy over distance, but with light, that constraint can be overcome in one leap.
However, manufacturing optical connections at scale is far from simple. It's not just about running fiber cables. The precision of optical coupling, where light enters and exits silicon chips, is extremely demanding. Even a misalignment of just a few microns can be fatal. There's another emerging challenge, the concept of known good photonic die. A chip may look electrically fine, but have poor optical coupling efficiency, or its wavelength characteristics may be slightly off. These new types of defects are appearing one after another on production floors. Traditional wafer testing only checks whether a chip works electrically, but in the era of optoelectronic integration, we also need to verify at the wafer level that chips work properly as optical devices as well. Form factor with Triton and Teradyne with Photon 100 have already begun competing in this space. Among Japanese companies, I'm closely watching how Advantest and Tokyo Electron will position themselves here. Optoelectronic testing is a completely different technical domain from traditional electrical testing, which means there's still plenty of room for new entrants. Optical communication devices and precision manufacturing are among the few remaining areas where Japanese strengths are very much alive. Let me wrap up. The next competitive frontier in AI infrastructure is not simply GPUs. It's optical connectivity, optoelectronic integration, CPO, and the wafer-level testing required to manufacture all of it at scale. I'm convinced that the ability to mass-produce optical interconnects will be the critical bottleneck that determines the outcome of the AI infrastructure race from 2026 onward. That's all for today. I'll keep bringing you semiconductor news and analysis. So if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.